Thanks for coming to my talk. I hope you had your afternoon coffee, and you really need it because I'm going to show stuff running at the same time on 4 different platforms. We are going to automate tests running on WPF, web, iOS, and Android. My name is Angel, and I work for Infragistics as an architect, but deep down in my heart, I have always been a hardcore developer. You know, I've missed literature classes to do BSD ports, and I am on Stack Overflow, GitHub, and just like you. In my company, Infragistics, we are doing software for a lot of platforms, and sometimes our customers see a component like the Windows Forms grid or the WPF chart, and they want the same component on another platform like web. And this means, what this usually means is that we'll have to take a team of 3 or 4 people who are actually automating this component, and we'll need to have the same number of people for the new platform. And this creates a lot of issues and technical debt, and we have tried with different approaches in order to alleviate this. And today I'm going to present one possible solution to this. So you can argue that a native app creates the best user experience for the target platform, and a lot of big companies have embraced this concept. For example, Facebook, they started with web, they rewrote their application to have a native experience, and some things like games and more interactive UIs, they need to be written in native. And this usually comes at a big price. And the question I would like to answer is, how do we make automating and testing those applications which are written for multiple platforms in a more robust and in an easier way? Okay. So before I continue, I would like to plot a simple chart showing the relationship between cost and value in the software that we are doing. So if we have low value and we don't have a big cost, we don't make any difference. I mean, there are thousands and hundreds of thousands of developers across the world and companies who try to do something with small value with nothing. And that's okay. I mean, we don't want to be in this quadrant. But where we really don't want to be is out there, because if we put a lot of money to something and we achieve small value, then we are really doomed to fail, and not only fail, but fail big time. So there are a lot of companies who are doing products which have high cost and add a lot of value. But the problem with this is that there is no competitive advantage, okay? So where we really want to be is here. We want to have a great value with a small cost, okay? So we want to reuse things. We want to, to have the same developers work on multiple platforms. We want to have a good level of automation. We want to decrease the amount of manual testing that we are doing. So this is a chart by Scott Gu, which shows very well the relationship between user experience and effort. So you can see that the native user experience, the native applications have consistent and high user experience. And sometimes it's those 5 or 10% that make the big difference. So we are not really satisfied with 90 or 95% of the functionality and user experience, which we can achieve with something like adaptive CSS. What we really want to do is our testing and our automation to take that much effort. So we have a number of really obvious choices. So we can write our tests in each platform's automation framework. So if you write an application on web and on WPF and on iOS, we can use the iOS framework or the WPF's UI instrumentation or Selenium WebDriver for web. But there are a couple of drawbacks to this. It's really hard to maintain in the long run. It creates technical debt, and it requires our developers to have knowledge in each framework. So you need to have guys who are very familiar with JavaScript, with Selenium WebDriver. You need to have guys who are very good with iOS. The same thing applies to Android. But what I really don't like about this approach is that it's not transparent. What this means is that we may soon end up with the same requirements that we need to implement for all the platforms. And if we have tests written separately for iOS and tests written separately for WPF or web, we'll soon have feature disparity, so we won't know what functionality the WPF version supports or what functionality the iOS version supports. And this is something we would like to solve. Okay. So one possible solution that I'm going to present is to abstract the test definitions by using domain-specific language and write these test definitions in Cucumber. And we are going to use behavior-driven development for that. So since our platforms are different, we would like to use something more abstract. We don't want to stick to iOS or stick to the WPF or to web. We would like to use something like Cucumber and then express our test definitions in a high-level language like gherkin. And then we would like to have a platform-specific driver, and this is the approach I'm going to talk about in my next slides and in my demo. And this platform-specific driver, we are going to implement it for every platform, okay? So if I have something like a simple to-do application, I'm going to have a to-do driver for every platform, and this driver is going to implement things like adding a task. So that task functionality in this driver will be different for every driver, okay? And the really good thing about this approach is that we are going to use the same development environment. In my case, I'm using Visual Studio, but the same thing you can do in Eclipse or WebStorm or RubyMine if you're using Ruby. So this gives us a number of advantages. On one hand, we use one ID, and we have a common source of IntelliSense, autocomplete. We use the same test runner. We are used to this look and feel. And then we can, of course, use the same continuous integration environment because we are using the same test runner. So some of you, and this is a question that I have received from a lot of people, including people from Infragistics and other companies. You can argue that we actually don't need to have the same features on all the platforms, but there are two main things I want to address with that. On one hand, it's actually good to have a specific scenario fail in a given platform because this gives us transparency. So if the add task is not implemented on iOS, the test will fail. And this is a good thing because I can immediately measure and I can immediately see that this specific user interaction is not available on this platform. And on the other hand, if you look back 2 or 3 years ago, you can see that a lot of the applications like Facebook and Twitter, they had most of their functionality implemented on web, and now you have everything on the mobile counterpart. So you have things like adding pictures to comments. This was added recently. And I think this will continue with time. So eventually everything will merge. So your customers will want the same functionality on all the platforms. And in this talk, I'm not going to convince you whether you should do native applications or whether you should do web only. This is not the point of the talk. So it assumes that you are actually doing multi-platform development and you need some testing approach. So I'm sure a lot of you know about Cucumber and about Gherkin, but for those of you who don't know, Gherkin is a business-readable, domain-specific language which actually lets you express customer requirements in a way that doesn't include implementation details. And I can give you an example. So this is a scenario implemented in Gherkin which performs adding a new task, okay? So this is the Gherkin format, the Gherkin language. And any implementation of Cucumber, no matter whether it's SpecFlow for .NET or the original Ruby implementation for Cucumber, or there's JavaScript, Java implementation. So any of those implementations will be able to parse this. So a Cucumber scenario consists of 3 different types of steps: given, when, and then. Given puts your system in a given state. So you ensure that your application has started, or if you're doing some connections, loading some resources, that they are actually loaded. The when steps perform the user interaction, so the things that your end user does, with the system. And then the then steps verify whether the system is in the correct state, in the expected state, after those interactions are finished. So here, I basically have a scenario to add a new task. given the to-do application has loaded successfully and the task list is empty, then when I add a new task with some text, I want to check whether the text of this task is, the expected one. And you can see that this scenario is really abstract. I can apply it to I can implement it in any platform, okay? And now I'd like to play a game. So in the context of multi-platform development and testing, can you tell me what's wrong with this scenario? And there are prizes, actually. We have 6 tickets for the Arena Cinema. We have some USB sticks, so anybody who answers correctly will get a nice prize. The ID, okay? So you're one winner? Nice, so this is great. Yes, it's not. So can you? Yes, that's right. And can you say something like specific about the things that are wrong? You are absolutely right.
Or you can just say when I click the to-do button or add button, and that will be the same button on all platforms, no application.
Okay. Right. So there are 3 main issues with this scenario. We don't have click everywhere. On mobile platforms, you are usually touching things, you are swiping, In 5 or 10 years, we may be waving, our hands and doing something like without even touching any device. And obviously, as many of you have said, we don't have buttons. Button is a platform-specific entity. So in iOS or Android, I may have something completely different. It doesn't have to be a button. My application may implement the same business requirement in a very different way. And of course, the worst thing, the most obvious thing is the ID. It's like it's not good to have implementation-specific, details in the scenario. And one good thing about multi-platform testing is that it actually forces you to have good scenarios. Because as you saw in my previous slide, I don't have anything like platform-specific here, and I should not. And even if I have, I'll soon realize that it's wrong. If I have something like this and I start implementing it for Android, I'll say, what's a click, So let me mention some things about the platform-specific drivers. So the drivers that I have, and I actually implemented the to-do application from scratch in 4 different platforms, and I'm going to demonstrate it to you today. The 4 drivers are actually based on some native UI automation framework. So the web driver is based on Selenium WebDriver. The WPF driver is based on UI automation. I mean, there are a lot of different choices. You don't have to use WebDriver, you don't have to use UI automation. In Infragistics, we have at least a couple of different frameworks that we can choose from. We are not using like UI automation, but I have tried to make something from scratch, which will be useful for all of you. So I have blogged about this, and you can actually download this zip file and ask me about it, and I can provide you with the code. And for Android and iOS, I'm using a very interesting project called Calabash. How many of you have heard about Calabash? Nice, good. So Calabash is basically a couple of things. It instruments your iOS and Android applications, and it starts a server, on the application. That's what it calls the server part. And then it has a client-side part, and it lets you write Cucumber scenarios, and then it sends commands to this server. So you can actually automate the same scenario on multiple platforms. So my drivers for Android and iOS are based on Calabash. But one thing about Calabash is that they are using their own protocol, and they have some console application, but the actual protocol is HTTP with JSON, okay? So I had to do some kind of reverse engineering, and I used some tools like Wireshark and TCP dump in order to actually sniff those packets and see what's the data which corresponds to a touch, what's the data which corresponds to finding some component. So I actually implemented this protocol in my driver, which is some .NET driver which uses an HTTP client as part of the driver. And you can implement, if you know the protocol, the JSON that you have to send, you can implement this in any platform. It works really well. This is basically the architecture of Calabash Android and Calabash iOS. So on one hand, you have the device or the simulator. So I have 2 laptops here. I have my iOS environment set up on this TV, and I have the simulator running. And those devices are connected to the SEC network, the Wi-Fi network. So if something doesn't work, you are probably using too many devices. But I want to make it really practical and real for you. So I have all my environment set up here. I have Android and Eclipse set up on this laptop. So that's going to be the server for the Android. So there is the device or the simulator part, and then I have a Calabash HTTP server or an instrumented app. So in iOS, they are starting a server, and in Android, they are instrumenting the actual app. It's slightly different, but the core idea is the same. So the core idea is that when you install your app, and it has this library reference in Eclipse or in Xcode, you actually, when you run this app in the simulator or in the device, it starts an HTTP server, and this HTTP server listens to a specific port, so you can send commands to it and get responses, okay? And you also have your app. So on the other hand, you have some development computer or build server, you know? It doesn't have to be like a developer machine. And you have your step definitions. So you have the Ruby client library if you are using vanilla Calabash, but in my case, I don't have that. I just have a custom HTTP client for iOS and for Android. And then I have my features, okay? So now I'm going to show you running code as part of my demo. And I'm going to also give you an overview about how those drivers are actually implemented. I have a to-do app written in 4 different platforms. I have test drivers written for all those 4 platforms. Test definitions are written in Cucumber, so I have the simple to-do, a simple to-do add task scenario implemented. And then all of my things are implemented in Visual Studio and use MS Test. So they could use any unit, anything. So then after I show this, I'm going to change my, my scenario, and then I'm going to rerun all the tests and execute again on all the platforms at the same time, okay? And what I want to mention here is that my Visual Studio basically consists of, my Visual Studio solution consists of several things. I have the web and the WPF applications implemented here because I can. So I have a web application, which is some ASP.NET MVC thing, and then I have a WPF application, okay? And then I have my test projects, okay? So I have a test project for Android, a test project for iOS, for JavaScript, and WPF. I hope you guys can all see this part from out there. If you don't see something, please let me know. So one important thing to note is that in my test projects, I have a feature file, and this is a Cucumber feature file. So this feature file implements a scenario, okay? I'm going to zoom a bit so that you all can see this. So the scenario is the same add new task scenario that I have shown to you a couple of slides back in my slides, okay? And then this feature file is actually shared across all the test projects, okay? And the implementation of these steps is also shared, okay? So if I open my iOS test project or my Android test project, you can see that these files are actually added here as links, okay? They are not new files. So those files link to these files. And if I change something here, it changes in all the test projects. If I go to an implementation of this step, so if I go to the add new task implementation, you can see that it's basically nothing platform specific. So I'm instantiating, let me zoom here so that it's more readable. So I'm actually instantiating a platform driver, okay? And then I'm adding a new task. The rest of the calls are not that important, but I wanted to see that this class is called in the same way in all of the implementations of the drivers. And just the implementation is different, but the class name is the same. So this platform driver is implemented in these framework projects, as I call them. So you have a Todorov platform driver everywhere in framework.android, framework.ios, and so on. And the implementation of the class is different, but the test projects, they actually reference the correct framework, okay? So this iOS project actually references the iOS framework. So it's a different version of this class, okay? And that's the beauty about it, because I can still link my feature files, I can still change them everywhere, but when they run, they instantiate a different class, okay? And they call a different automation technology. They call HTTP with Calabash, or UI instrumentation, or Selenium WebDriver. It doesn't matter. I have chosen these frameworks because of their diversity, but in your company, you may do web and iOS, or Android and iOS. So, okay. So let me open the web application. So I have an Eclipse with my to-do application implemented here, and the to-do application is really simple. It's just an input box with a button, and then I have some list, and the list is bound to some data source, okay? So whenever a new item gets added to this data source, then this refreshes, this list refreshes. I have started my Android simulator here. Okay, and then I'm going to show you how the web application looks like. It's a simple input box with a button, and then it will visualize some, unordered list structure below the to-do list element, okay? The iOS version is pretty similar to the Android one. It's basically an input box with some, iOS button and some table view, okay? So I have implemented a table view delegate in this iOS application, and when a new item is added, it rebinds and refreshes. You can implement this in so many different ways. The only point I would like to make here, which is important, is that your scenario is the same. So you have basically not only the same scenario, but the same step implementations. And actually, in Visual Studio, and I guess in most other Cucumber implementations, there is a code which gets generated by the design time support. So you have not only the feature file, but the feature.cs file, which is, for some of you who are familiar with ASP.NET, you may know what code behind this. So this is it actually uses the feature file and the step implementation and generates some code using your test runner of choice, which is MS Test. So all of this is reused in the test projects. Okay, so now I'm going to start those tests at the same time, and you are going to see them executed on all the platforms. The Android one is going to be slowest. Okay, so you see it enter some text, don't forget to go to work. It starts the web version, does the same. Now it will do the same in the Android version, but the emulator is a bit slow, so now it will click the button and touch the button. So let's see if it will all pass. Okay. So I have the test passing on Android, I have the test passing on iOS, on JavaScript, and on WPF. And let's see how, because the WPF and the web are probably not so interesting, even though it just worked like that. You saw the WPF application opening, and then this text entered, and then the verification was done using UI automation. Let me show you some details. So this is the implementation of the platform driver for WPF. I don't want to go into full screen because last time I did that, there were some crazy things happening because of the refresh rates and all of the things. So this is basically using the automation element from System Windows Automation. It's sending this text and waiting. So it's using Selenium WebDriver to do something similar for the web version. It's starting the URL, then finding the element, and then sending the keys using the WebDriver API. And with the iOS and with the Android version, it gets really interesting. So for those of you who want to try this at home, I can give you a hint that if you want to capture the packets, you cannot just use Wireshark on the loopback interface on Windows because it doesn't work. What I did is I used raw cap, captured a dump file, and then opened this dump file in Wireshark in order to see what the packets are. It will just save you some time. And for OS X, I just use a tool called HTTP Scoop. And this is the sequence of post requests that happens. Let me open one of them. I'm sorry if you cannot read this, but this conference room doesn't have the big screen, so the organizer had to bring this for me, for which I'm pretty thankful to them. So here we are sending a key. It's JSON format, and we are sending a base 64 encoded string. And you may think this is a magic number. Actually, what this is that it encodes a touch event for iOS 5 on the iPhone. And those strings are available in the Calabash GitHub repository, and I just took them from there and injected them in my request. So they just want to encode the different touch events on different devices with different base 64 encoded strings, okay? So if you are wondering what this is. And the result is just some object, JSON object, which says, the outcome is success, and that's what I'm interested in. And you can touch on touch elements, you can query elements. So if I query the table view, the query is really simple. I just do a query table view, and then my response is basically an object which includes the coordinates, the center coordinates, and then I can use those center and X and Y coordinates in order to touch them with some different command, okay? So now what I'm going to do is I'm going to actually stop all my applications. Of course, you can do that automatically with some command line scripts, but I didn't bother, to go that deep because anybody, can do it, can add some bash or bad files in order to restart the devices. And then I'm going to change my test scenario, okay? So I want to change my test scenario, the text of the task I want to add, because some manager, came to me and said that he wants me to test some specific string, okay? Whether it's a short string, a long string, some Bulgarian string, okay? It happens all the time with UIs. So I'm going to open any of those tests are actually pointing to the same file, so I don't care which one I'm going to open. I'm going to open the first one. And then I'm going to change this go to work to something like eat hamburger, okay? So I'm feeling hungry. I'm just making this text now. I'm not, it's not a magic string or something. Okay. Now let's see if I rerun those tests. You notice that I didn't change anything at any different place. I just changed it here, okay? Now let's rerun those tests and see what happens. If we are lucky, they should pass all again, okay? So now we have to wait for the Android version. Yeah, a lot of Android developers, they actually don't use the emulator, and that's what, if I was doing applications for Android all day, I wouldn't use this emulator, but now it just makes it more complex for me to add real devices and stuff like that. So all of the tests passed, and I guess you can see the value of this approach already. It's not only about the same development environment, but it's about complete reuse. So your scenarios are in one place. If something changes, or if you want to test something different, you don't have to make changes everywhere. And it basically makes it very transparent and consistent what you are testing and what the features are in every different platform. Okay, I'd like to go back to my slides now and give you, again, an overview about how each call happens. So I have my step definitions, then I invoke the platform driver, then the platform driver invokes the automation framework, which is Selenium WebDriver UI automation, or this custom driver that I wrote for Calabash Android and Calabash iOS. And then this framework on the actual device or in the browser, it invokes something specific. So the WebDriver part in the browser may actually call some native browser API, or the UI instrumentation framework in WPF, it may try to find this element on the screen using system accessibility, and it will invoke the native action which corresponds to clicking a button or touching some element or swiping or whatever. And before I finish with my presentation, I would like to list some of the advantages of this approach again. So you have complete reuse of both test definitions and the test implementation. You focus on the business requirements. It forces the test definitions to be abstract and good. You use one ID. You have the same test runner, and because you have the same test runner, you can use the same continuous integration process. So you can use Team Foundation Server or Jenkins or whatever you use in your own company. And let's see what's the return of investment in actual real numbers. So let's say a test costs $50. And this is just some number. It may be different for each one of you. But it doesn't include just the cost of development of the test, but the cost of the maintenance, the cost of the hardware where this test runs, and all of those things associated with writing a test. So let's say it costs $50. And you have 4 platforms, 1,000 tests, $200,000 to write those tests, in a standard way, which is, you write it for every platform. And now let's assume, this is an assumption, let's assume that the cost of writing the platform drivers over time is 0 if the number of tests becomes infinite, okay? And what I mean by this is that it assumes that you have this driver, it has some API, and you just reuse it for all of the tests that you write, okay? You can immediately see the huge difference in price. Now think about the fact that in Cucumber, you can actually take any scenario in any, any step in any scenario and reuse it in a different scenario. So I can take, if I have my add task implemented, I can take it and use it in a different scenario. So this adds additional value. Okay, and basically that's what I wanted to convey to you today. I hope you enjoyed it. If you have any questions, you can send me a mail. I don't have my mail here, but I'll add it. And obviously you have it in the booklet, and you can find it in Okay. So if you have any questions, please let me know. I have all of this described in a very detailed way on my blog, blogsinfragistics.com/Angel_Todorov. And I can send you the zip file, or we can discuss some improvements. This is actually, this approach is used in automating our data chart component, which is implemented on multiple platforms. And those tests run every day. Maybe they are running now, who knows? But it's not something like some theory that just stays on slides and proof of concepts. It's actually an approach that we use right now in our company. Okay, do you guys have any questions?
Okay, I can do it without the mic. So is this the format you're maintaining your backlog as well?
Could you repeat? I couldn't hear very well.
Is this also the format you're maintaining your backlog as well?
So it depends on the product and on the team. Right now, we started using Cucumber, recently. By recently, I mean about 1 year ago. In my talk last year in ISTA, I was talking about using Cucumber to auto-generate test beds. Okay, so we use it in our Ignite UI product, which is relatively new, and we are starting to use it in specific components in other teams, like the chart. So right now, this approach is used in some of the teams, but not in the whole company. And we are trying to, to use it in more teams gradually. So it won't happen, at once, but we are convinced that this is a good approach, and it's actually, we have proven that it works in reality. That's most important, I think. It's a great question. I mean, thanks. We tried to roll it out in specific teams first and see if it works, and then we were convinced that it's good, and we try to use it now we try to use it in more and more teams and products. Do you guys have any other questions? Okay, great. Thank you very much again for your participation.